Welcome to Teju's Academy.
Let us start activities in acid-bases salts lesson.
What is activity 2.1 we have here? You see here some of the activities given in your textbook. Activity 2.1, so changes in the color you see. Acid, red litmus solution, they don't give any color change. Okay, red will give red only, right? That but red litmus of the solution acidic will they don't give any color change. But when this red litmus solution, when you pour in any bases, it will give blue color. Right? Similarly, blue litmus solution changes acid to the red color, but bases will not give any color change. Similarly, phenolphthalein will not consist any color changes. So these are the colorless when you add phenolphthalein acidic medium. So there is no color change. So when you add this phenolphthalein, the bases, these are the bases, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, so it will give the pink color, right? Pink color, it will give pink color, becomes colorless after some time, right? So next, methyl orange solution. When you add this methyl orange solution to the acid turns to red color. Then this methyl orange solution, when you add to the base, and bases turns to yellow color and becomes colorless after some time. When you keep like this, it will colorless sometime. So all factor indicators. What is mean by all factor indicators? Activity of all factor indicators and natural indicators. We are taking some cloth strips when you kept in a bag with finely chopped onions. So left overnight you are keeping these onions with cloths in your fridge. After taking the cloth strips, when you add dilute HCl, we can smell the onion. Right? Red color of the cloth strip changes to the pale red. Red color of the cloth strip changes to the pale red when you add the dilute acid. So we can observe the onion smell when you add the acid to that cloth strip. When one of the cloth strip you take one more cloth strip, you add dilute NaOH solution to that. Then this will changes to red color of the cloth strip changes to the green. The color of this cloth strip changes to the green, and also we cannot observe this smell of the onion when you add the NaOH solution. We cannot smell the onion. Okay, and also this cloth strip red color strip changes to green. This is the activity 2.2, that is about all factor indicators. Next example to order test. Vanilla essence, when you add vanilla essence to dilute HCl solution, the smell of vanilla essence exists. We can observe that smell of vanilla. But when these vanilla essence, when you add to the dilute NaOH solution, we cannot observe the smell of the vanilla. Okay. Now clove oil. When you add clove oil to dilute HCl, we can observe the smell. But this clove oil, when you add it to the NaOH solution, we cannot observe the smell. Smell of the cloves does not exist. Okay. So all these experiments you can confirm that. So in HCl medium, we can observe the natural smell of vanilla and clove oil and onion. But in basic medium, we cannot observe the smells. Okay. So this is about all factor indicators. Next, this is about the reaction between the acid and metal. When you add acid to the metal, it will give hydrogen gas. So hydrogen gas is formed. How will you test this hydrogen gas? So this we can test by passing hydrogen gas. On passing hydrogen gas evolved through a soap solution bubbles. Uh, yeah. On passing hydrogen gas evolved through a soap solutions, bubbles are formed. When this burning candle near the gas filled bubbles, when you take it nearer to the gas, this candle will give pop sound. Okay, the hydrogen gas will give thump, like that sound will come. When you take the burning candle nearer to the hydrogen gas, it will give thump sound. That is we call pop sound, right? So in this way we can test the hydrogen gas. Same thing here also happen when you add a reaction. So here you take the activity 2.4 in your textbook, reaction between the base and metal. When granulated zinc reacts, when you add to the sodium hydroxide, what will happen? Some hydrogen gases will evolve. How will you test this hydrogen gas? On passing hydrogen gas evolved through a soap solution, this hydrogen gas you are passing through the soap solution. In the soap solution, you will get some hydrogen bubbles. So burning candle, when you take it together, so when you take it nearer to the these bubbles, this burning candle gives one top sound, pop sound it will give. Okay. Next, yeah. Reaction with the acids and metal carbonates. When acid react with the metal carbonates or metal bicarbonates, it releases CO2 gases, right? CO2 gases, salt water. Then how will you test this CO2? How will you test this CO2? You are passing the CO2 gas through a lime water, so it turns to the milky because insoluble precipitate of calcium carbonate is formed as shown in the below, right? Now, on passing excess CO2 through this lime, this what will happen? So, how will you get this white color precipitate when CO2 is passing through the calcium hydroxide? That is lime water. Lime water. When you pass these CO2 gases through the lime water, it will give white color precipitate. So it will give milky color, milky like milk. What is the color of the milk? Like that milk color we can observe here. Okay, so again you are passing excess amount of CO2 to this white PPT. Then what will happen? This white PPT, calcium carbonate, will react with the excess amount of CO2 and form as calcium bicarbonate. So which is soluble in the water. It will not give precipitation. It is soluble in the water. So this is activity 2.4 and activity 2.5 is over. Next activity 2.6. Activity 2.6, we are taking the acids and bases. You are using phenolphthalein indicator. Then what will happen? When you add sodium hydroxide to phenolphthalein, it will give pink color. When you add this phenolphthalein to the acid, it will give colorless. Okay. What we are taking here, reaction between the acids and bases. So first we are adding bases. First we are adding base to the phenolphthalein indicator. It will give pink color. To this base we are adding acid, right? Then the pink color slowly get disappear. What we are taking one test tube, right? So in the test tube we are taking base NaOH. To this we are adding the phenolphthalein indicator. Then this, when you shake this test tube, the color of the test tube will become pink. Means the sodium hydroxide turns phenolphthalein into pink color. To this same test tube, we are adding the HCl, some amount of HCl. Then what will happen? This HCl react with the NaOH. It will get salt and water. That means the pink color will get slowly disappear. To these, again you are adding the NaOH again. Again you are adding the NaOH. This solution turns to again basic in medium. Again the pink colors will get appear. So in this manner we can see here. So reaction between the acids and bases. So acids and bases nullifies other effect. Acids and bases react with each other to form salt and water. Okay, this is activity 2.6. Next activity 2.7. So what is activity 2.7 we have here? Here copper oxide in beaker, we are taking copper oxide, CuO, copper oxide. So we are adding diluted HCl. We are stirring it. Then what will happen? The copper oxide will react with the HCl. The blue-green color will form due to formation of the CuCl2. Okay, this is a metal oxide. Metal oxides are in basic in nature. When it is react with the acid, it will give CuCl2 plus water. CuCl2 plus water. Okay, so metal oxides reacts with the acid to form salt and water. Metal oxides set as a base here. So metal oxide plus acid, it will give salt and water. Next you see activity 2.8. Then conduction of electricity by acids and bases. Acids conduct electricity. How will you prove these acids conduct electricity? You see here, we are taking one beaker, so we are taking two names. We are adding to the one bulb, right? We are adding to the one bulb. We are adding to the battery. No. We are adding to the bulb directly itself, right? What will happen here? When some chemical reaction taking place, this bulb will glow. So we are adding to the battery. Yes, we are taking battery here. Okay, so we are taking two wires. We are adding bulb also in series, right? Battery, bulb, wires. We are connecting like this. Okay. Now, when you switch off this battery, what will happen? What will happen? You are taking HCl solution. You are keeping two nails in the HCl solution. The bulb will glow. When you take it up from the solution, the bulb will not glow. When you take HCl, the bulb is glowing. When you take H2SO4, also bulb is glowing. That means it conducts electricity. It carries some electricity through it. But when you take glucose, the bulb will not glow because there is no dissociation. The bulb will not glow, right? When you keep two nails, you are taking beaker, right? In that beaker, you are pouring the glucose. You are keeping two nails into the beaker. You are switching on the battery. After some time, what will happen? The bulb will not glow. You are taking what here? You are taking organic compounds, organic substances. When you dissolve in the water, it won't give ions. If there is no ions, there is no current flow through that, right? If there is ions, there only current pass through that ions, right? So when you dissolve the glucose and alcohol, what will happen? The glucose and alcohol will not dissociated as ions, so bulb will not glow. So when you take base, sodium hydroxide and calcium hydroxide, what will happen? The bulb glows again. Why? Because the sodium hydroxide and calcium hydroxide, when you dissolve in the water, it releases OH minus ions. Due to that, bulb glows, right? So that means it. From this experiment, we came to know that acids and bases release some ions. Due to that, it conduct electricity, right? Due to this, it conduct electricity. When it is releases ions, when you dissolve in the aqueous, when you dissolve in the water, acids and bases release ions. So through these ions, the current is passes. That means acid and bases conduct electricity. Acids and bases conduct electricity. Now here we have the activity 2.9. So in that activity 2.9, what we are doing? Acidic property of the acids only in aqueous solution. Acidic property of acids only in aqueous solution. So you are taking some concentrated sulfuric acid. To this you are adding dry sodium chloride in the test tube. So it emits some hydrochloric acid in the gaseous form. Okay, what we are taking here? Acidic property of the acids only in aqueous solution. What we are taking here? Concentrated sulfuric acid we are taking. So that sulfuric acid you are adding salt. You are taking test tube. In the test tube, what we are taking? H2SO4. To this, we are adding the salt. Then after some time, what will happen? It emits HCl gas, right? It emits HCl gas to acidic nature in presence of the water. Okay, how that acid will act as acid? How that bases will act as the bases? Acid will access when it is contact with the water. When it is contact with the water, acid when it is contact with the water, it releases H plus ions. Okay. If it is not contact with the water, the acid will not release H plus ions. Okay. So that we cannot consider as acid. So when you consider as acid is acid, when you consider acid actually how when it is acted as actual acid, when it is contact with the water, then only it releases H plus ion. The acid, the substance which releases H plus ions in aqueous solution is called as acid. Okay, if you are not adding the water, so it won't give the H plus ions. To perform that activity, what we are doing, we are taking the H2SO4. To this, you are adding the NaCl salt. Then what will happen? HCl gas fumes evolve from that test tube. HCl gas fumes will evolve from that test tube. And these HCl gases, you are drying with some litmus. Okay, when gases HCl is expected to the, first we have to dry this HCl. How we are drying this moist HCl? By keeping some moisture absorbing material we have to keep here. So the moisture absorber material, what it will do? It will drag the moisture from the acid, and the acid gases will become dry. When this dry HCl, there is no water in the HCl. When this dry HCl, when you keep in blue litmus paper, it will not change the color red. Okay, already we know that the blue litmus paper changes red in acidic medium. Okay, this is HCl. This HCl gas also acid. So, but it's the dry HCl. So, when dry HCl contact with that paper, it will not give any color change. Why? Because there is no moisture. If there is no moisture in the dry HCl, it won't give the H plus ions. Okay. If there is no H plus ions, there is no color change in the blue litmus paper, right? So second time what we are doing, we are moistening this HCl gas. We are adding some water drops, or we are moistening. We are not keeping that water absorbing powder. We are as it is, we are passing through like that. So this HCl gas consists of water molecules. So due to presence of water molecule in the HCl, what will happen? This HCl dissociated as H plus ions. And when it is dissociated H plus ions, now you keep some blue litmus paper nearer to that. What will happen? This blue litmus paper, now it will changes to the red litmus paper. Why? Because this HCl in the presence of water, it releases H plus. This H plus when contact with the blue litmus paper, it turns to red color. So in this way we can perform the activity. So acids, acidic property of acids, when it will perform only in aqueous solution. Okay, when will you say that acid is actual acid? When it will behaves as acid, when it is dissolved in the water, then only it behaves as acid. Otherwise, it won't behave as acid, right? Same base also like that only. Now, yeah, here acid release H plus ions in the aqueous solution. Acidic property of the acids is exhibited only in aqueous form, only when H plus ions are present, right? So when that acids release H plus ions, when there is aqueous solution, then only it will give the H plus ions. Okay. Then acidic property of the acids is exhibited only in the aqueous form, only when H plus ions are present. Next activity, dilution of the acid or base. When you add water to the acid, it releases some heat. So this we can observe. You take some acid in test tube, you add water drop, or you take water. First, you have to take water. You have to add. You have to add acid to the water, not water to the acid. Okay, if you add like that, it will release more amount of heat energy, and the reaction will splash out. Okay, that acid will splash out. When you add acid you are taking in beaker, you are pouring the water. That is okay. Then what we are doing here? No, that is not okay, sorry. So acid we are taking, you are adding base, that is not suggestible. What we have to do, you have to take more amount of water. Water, actually the temperature of the water is very less compared to acid, right? So you are taking more amount of water, through this drop wise you are adding the acid, then it is suggestible. If you make it reverse, this it is not suggestible. So you are taking more acid, you are adding the water, means the acid will come out and splash out your face, right? Then face will get burned. Face will get burned. It will come out from the beaker. It splash out suddenly when you add the water to the. What will happen? So what we have to do here? You have to take more amount of water. Drop wise, you have to add acid to that. After some time, so during that reaction, what will happen? Heat is released. Excess amount of heat is released. When you touch the beaker, we can feel the heat. Okay, that means the beaker becomes hot. Okay, so when concentrated sulfuric acid is added to the water, when sodium hydroxide pellets are added to the water, the beaker becomes hot, right? When H2SO4 added to the water, it will become heat, and sodium hydroxide, when it is added to the water, it will become also heat. So dilution of acid is an exothermic reaction. Dilution of base is an also exothermic reaction. Exothermic reaction, the reaction in which heat is released, means that reactions we called as exothermic reactions. Next activity 2.11. We take activity 2.11. We have the pH values of the solutions. Saliva, yeah, color of the pH paper. Yeah, pH paper is a universal indicator, right? So in neutral medium, it will give the green color. In acidic medium, it gives the pale yellow color. In very acidic medium, it will give the pink red color, right? Pink red, orange, right? In acidic medium, it will give red, pink red, or orange red, right? Reddish color. It will give reddish color. Neutral medium, pink color. Light green, sorry, neutral medium, light green color, right? Now basic medium, violet to blue color. Remember all these things. pH paper is the universal indicator. So when you take saliva, you add to the saliva. pH paper you take, just you touch your saliva, then pH paper will become light green color. Actual color of the paper is light yellow, I think, light yellow. So when you touch this paper in your, when you keep in your mouth, so the color of the paper, pH paper will change to light green. Then what is the approximate pH value we will get here? 7.4. The nature of the substance is base, right? So after meal you are taking saliva. So after meal, our mouth will become acidic, right? Saliva will become acidic in meal. So after meal, the pH value is 5.8. So that pH paper value gives pale yellow color. Before meal, our saliva in our mouth is in neutral medium. That will give pH 7.4. After taking food, what will happen? After taking food, what will happen? The bacteria which are present in the mouth, so it degrades the food and it releases some acids, right? Due to that, the saliva pH will come down to 5.8. Okay, acidic nature. After meal, the saliva will become acidic nature. Before meal, that is in basic or neutral medium. Colorless aerated water. Colorless aerated water, you take Sprite, Sprite you take, 7 Up you take, colorless you take. And, why? Because if you take color means you cannot observe the color change. That's why you are taking. That's why we are taking the colorless aerated drink. So what are the examples for the colorless aerated drink? Sprite, Thumbs Up, right? So when you take this colorless aerated drink, so when you add this pH paper to the drink, so what will the change of the color of pH paper will become pale yellow. Why? Because the colorless aerated drink having the pH value less than 6, less than 7, that is 6, that is acidic medium. Carrot juice also acidic medium. That will give you light orange color. When you dip the pH paper in carrot juice, it will give light orange color. The pH value of the carrot juice is 4. And also coffee. So coffee acidic medium. Coffee also acidic medium, right? So orange yellow. Tomato juice acidic medium, dark orange. Tap water, that is neutral medium, that will give green color. So 1 molar of NaOH when you take, it will give dark blue or violet color. The pH of the 1 molar NaOH is base, right? So when you take HCl, HCl is the strong acid, right? When you dip the pH paper in HCl, it will give red color. The pH value of the acid is 1. This is activity 2.11 over. Next activity 2.12 to soil test. This is the soil test. How we are testing the soil? So we are taking 2 grams of the soil in the test tube, right? The test tube you are taking, you are adding the soil, you are pouring some water, and you are mixing it properly. Okay, so after that you are filtering. Okay, so you will take filtrate, then check the pH value by putting universal indicator or universal pH paper also we can use, or also we can use the pH meter. So when we do the pH pH values of soil here, pH equals 7 means neutrals, plant grows well. If it is greater than 7, plants are affected. If it is less than 7 also, plants are affected. Okay, now you see forms of the salts, formula of the salts, right? What are the formulas of salt? Potassium sulfate. How this salt is forming? From acid and base, H2SO4 KOH. Because of combination, this potassium salt will form. Okay. Next, when Na2S, how you are getting Na2SO4? When strong base NaOH added to the strong acid, you will get sodium sulfate. That is neutral salt. When strong acid react with the calcium hydroxide, strong sulfuric acid react with the strong calcium hydroxide, it will give calcium sulfate, neutral salt. Magnesium sulfate, how we are getting? Because of reaction of sulfuric acid and magnesium hydroxide, you are getting magnesium sulfate. Because of reaction of H2SO4 copper hydroxide, you are getting copper sulfate. Because of reaction of the HCl and NaOH, you are getting NaCl. Because of reaction of HNO3 NaOH, you will get NaNO3, sodium nitrate salt. Because of reaction with the weak acid, carbonic acid, and the strong base NaOH, you will get basic nature of sodium carbonate salt. Here we are using strong acid and weak base. So here acid is strong, so salt formed here acidic in nature, ammonium chloride. Okay. Next, nature of salt solution. Sodium chloride is a neutral salt. Why? Because it is forming from the strong acid and strong base. Potassium nitrate also neutral salt. Why? Because it is forming from the strong acid HNO3, strong base KOH. Ammonium chloride also acidic in medium. Ammonium chloride acidic in medium. Why? Because ammonium chloride is forming from the strong acid HCl and weak base ammonium hydroxide. So here which one is the strong? HCl is the strong. So we are getting the ammonium chloride is acidic in nature. Then zinc sulfate also acidic in nature. Okay, zinc sulfate, what are the acid we are using here? H2SO4 and zinc hydroxide. H2SO4 is the strong acid and zinc hydroxide is weak base. Here acid is strong. Here acid is strong. So zinc sulfate nature is acidic, right? Copper sulfate also acidic. Why? Because here acid is strong. Here acid is strong. Copper hydroxide is weak. H2SO4 is strong, right? Strong acid, weak base. So that we are getting here acidic salt. When will you get the basic salt? Sodium acetate. Here, here acid is weak, right? Weak acid, reaction between the weak acid and strong base NaOH. It will give sodium acetate salt, which is in the basic nature. Why it is in basic nature? Here base is strong, NaOH base is strong. Next, sodium carbonate. Sodium carbonate also basic in nature, Na2CO3. That is we call as washing soda. Here carbonic acid is a weak acid, sodium hydroxide is the strong base. Here base is strong. Due to this, we are getting basic meaning basic nature of salt, sodium carbonate. Okay. Then sodium hydrogen carbonate also basic in nature. Why? When will you get this basic salt? So when acid H2CO3 used, weak acid H2CO3 combined with the strong base. Here base is strong. That's why we are getting basic nature salt, sodium hydrogen carbonate. This is the nature of salt, activity 2.14. Next activity 2.15 you see water of crystallization. Already I told you this.
Please subscribe our channel. Thank you for watching.